In this module, we will study about the expectations augmented AD and AS curves. The aggregate demand and aggregate supply relations are some important relations in macroeconomics. The model of aggregate supply and aggregate demand describes the movements in output and the price level when account is taken of equilibrium in the goods market, the financial markets and the labor market. The aggregate demand relation captures the effect of the price level on output. It is derived from the equilibrium conditions in the goods and financial markets. The underlying negative relation between output and the price level is called the aggregate demand relation. The aggregate supply relation captures the effects of output on the price level. It is derived from equilibrium in the labor market. It is a relation among the price level, the expected price level and the level of output. An increase in output decreases unemployment. The decrease in unemployment increases wages and in turn increases the price level. An increase in the expected price level leads one for one to an increase in the actual price level. In the short run, movements in output come from shifts in either aggregate demand or aggregate supply. In the medium run, output returns to the natural level of output which is determined by equilibrium in the labor market. These relations along with the Phillips curve and its modified version are discussed below. Also, the relation between actual unemployment rate, natural rate of unemployment and the change in inflation rate has been described. The Phillips curve was not part of the initial Keynesian model, but because it provided such a convenient and apparently reliable way of explaining the movement of wages and prices over time, it had become part of the new classical synthesis. In the 1960s, based on the empirical evidence up until then, many Keynesian economists believed that there was a reliable trade-off between unemployment and inflation even in the long run. After studying this module, you shall be able to understand the aggregate demand and aggregate supply relation, understand the relation between inflation, expected inflation and unemployment, understand Phillips curve original as well as expectations augmented, understand the relationship between actual unemployment rate, natural rate of unemployment and the change in inflation rate. Let us commence our module with aggregate demand curve. The aggregate demand relation captures the effect of the price level on output. It is derived from the equilibrium conditions in the goods and assets market. The equilibrium equation for the goods market is y is equal to C y minus t plus I in bracket y small I plus g. Equilibrium in the goods market requires that output equals the demand for goods, the sum of consumption, investment and government spending. This is the IS relation. The equilibrium equation for the assets market is M upon P is equal to Y L in bracket small I. Equilibrium in asset market requires that the supply of money equals the demand for money. This is the LM relation. Using the IS and LM relations, we can derive the relation between the price level and the level of output implied by the equilibrium in the goods and assets market. The initial position where both the goods and the assets market are in equilibrium is at the intersection of the IS and LM curve at point A. Now suppose price increases from P to P dash. Given the nominal stock of money supply, the real money supply decreases with the increase in price. The LM curve shifts up as at a given level of output due to decrease in real money supply, the interest rate increases. The economy moves along the IS curve and the new equilibrium is established at A dash. The interest rate increases from I to I dash, output decreases from Y to Y dash. So an increase in the price level leads to a decrease in the output, implying a negative relation between the two as represented by the AD curve. Any variable other than price level that shifts either the IS curve or the LM curve also shifts the aggregate demand curve. The aggregate demand function that we have just derived can be represented as y is equal to y function of m upon p g t. Output y is an increasing function of the real money stock m upon p, an increasing function of g or government spending, and a decreasing function of taxes t. The aggregate supply relation captures the effects of output on the price level. It is derived from the behavior of wages and prices. The equation for wage determination was given by W is equal to expected price function of U, Z. The nominal wage W set by wage setters depends on the expected price level P raised to the power E, on the unemployment rate U, and on the catch-all variable Z for all other factors that affect wage determination, from unemployment benefits to the form of collective bargaining. The equation for price determination is P is equal to 1 plus mu into W. The price P set up by firms is equal to the nominal wages W times 1 plus the markup mu. Substituting value of W and using previous equations, P is equal to expected P into 1 plus mu into function of U, Z. In order to get a relation between price and output, replacing the unemployment rate U by its expression in terms of output, small u is equal to capital U upon L is equal to L minus N upon L is equal to 1 minus N upon L is equal to 1 minus Y upon L. The first equality follows from the definition of the unemployment rate. The second equality follows from the definition of unemployment. The fourth equality follows from the specification of the production function, which says that to produce 1 unit of output, 1 worker is required, so as to make Y is equal to N. Substituting the value of U from previous equations, P is equal to expected price into 1 plus mu function of 1 minus Y upon L, Z. This is the aggregate supply relation. The price level depends on the expected price level, the level of output, the markup, the catch-all variable Z, and the labor force. Price increases with an increase in output and also with an increase in expected price level. The relation between the price level P and output Y for a given value of expected P is represented by the following figure. The aggregate supply curve is upward sloping and it passes through a point P where Y is equal to Yn and P is equal to expected P. Moving on to inflation, expected inflation and unemployment. Aggregate supply relation between price level, the expected price level, and the unemployment rate is given by P is equal to expected P into 1 plus mu into function of U, Z. In this equation, function f captures the effects on the wage of the unemployment rate U and the catch-all variable Z. F is a function of U, Z is equal to 1 minus alpha into U plus Z. This equation captures the negative relationship between unemployment rate and wages and the positive relationship between other variables like a more generous employment benefit, etc., and wages. Using previous equations, P is equal to expected P into 1 plus mu into 1 minus alpha u plus z, and let sigma denote the inflation rate and sigma raised to the power e denote the expected inflation rate. Then equation X can be written as inflation is equal to expected inflation plus mu plus z minus alpha u. This equation explains the relationship between inflation, expected inflation, and unemployment. This implies inflation is positively related with expected inflation, markup, and variables captured by Z, while it is negatively related with unemployment rate. Moving on to Phillips curve, original and expectations augmented. Original Phillips curve. The original Phillips curve is given by the equation inflation in time period t is equal to mu plus z minus alpha u. This can easily be understood if one knows about the time period and the conditions in which Phillips, Samuelson and Solow worked. During their study period, average inflation was close to zero. Since the average inflation over the past years was zero, it was reasonable to expect that inflation would be zero over the next year too. This implies expected inflation is equal to zero. This is precisely the negative relation between unemployment and inflation that Phillips found out for the United Kingdom and Solow and Samuelson found out for the United States. But then two changes took place in the behavior of the rate of inflation during the 1960s. First, from being sometimes negative and sometimes positive, the rate of inflation became consistently positive. And second, inflation became more persistent, that is high inflation in one year became more likely to be followed by high inflation the next year. This led the firms to revise their expectations. This change in expectation formation changed the nature of the relation between unemployment and inflation. Let expectations are formed according to expected inflation in time t is equal to theta into expected inflation in time t minus 1. The value of the parameter theta captures the effect of the last year's inflation rate on the current year's expected inflation rate. Samuelson and Solow had looked at theta close to zero, but as inflation has become more persistent, theta is positive and somewhere close to 1. Using previous equations, inflation is equal to theta into inflation in time t minus 1 plus mu plus z minus alpha u. When theta is equal to 0, we get the original Phillips curve, a relation between inflation rate and unemployment rate. Inflation is equal to mu plus z minus alpha u. When theta is positive, the inflation rate depends not only on unemployment rate but also on last year's inflation rate as depicted in this equation. When theta is equal to 1, the relation becomes inflation minus inflation in time t minus 1 is equal to mu plus z minus alpha u, implying that the unemployment rate does not affect the inflation rate but rather the change in inflation rate. High unemployment leads to decreasing inflation and low unemployment leads to increasing inflation. This is the expectations augmented Phillips curve, or what others call modified Phillips curve or accelerationist Phillips curve. Next, we will study relationship between actual unemployment rate, natural rate of unemployment and the change in inflation rate. At the natural rate of unemployment, actual price level is equal to the expected price level. This implies actual inflation rate is equal to expected inflation rate. Thus, equation becomes 0 is equal to mu plus z minus alpha un. Solving for un, we get un is equal to mu plus z upon alpha. Using previous equation, inflation in time t minus expected inflation in time t is equal to ut minus mu plus z upon alpha minus alpha. Therefore, we get inflation in time t minus expected inflation in time t is equal to ut minus un minus alpha. This gives us another way of thinking about the Phillips curve as a relation between the actual unemployment rate, the natural unemployment rate, and the change in the inflation rate. When the actual unemployment rate is higher than the natural rate of unemployment, the inflation decreases and vice versa. Now, let us summarize what we have learned. The aggregate demand is represented by Y is equal to Y is a function of M upon P, G and T. Y is positively related to the real money stock M upon P and government spending, while it is negatively related to taxes. The aggregate supply relation is represented by P is equal to expected price into 1 plus mu into function of 1 minus Y upon L comma Z. The price level depends on the expected price level, the level of output, the markup, the catch-all variable Z and the labor force. The relationship between inflation, expected inflation and unemployment is given by inflation is equal to expected inflation plus mu plus Z minus alpha u. This implies inflation is positively related with expected inflation, markup and variables captured by Z, while it is negatively related with unemployment rate. The negative relation between unemployment and inflation was found by Phillips and originally represented as inflation in time period t is equal to mu plus z minus alpha u. The expectations augmented Phillips curve shows the relation between unemployment rate and the change in inflation rate through the equation inflation minus inflation at time period t plus 1 is equal to mu plus z minus alpha u. The relationship between actual unemployment rate, natural rate of unemployment and the change in inflation rate is given by the equation inflation at time t minus expected inflation in time period t is equal to ut minus un minus alpha.